magnetic properties of our elements can give us some information about their electron configurations, actually. So when we look at magnetic properties, there's two things we're looking at. Are we attracted to a magnetic field, or are we repelled by a magnetic field? So paramagnetic, these are configurations that result in unpaired electrons. This means that they will have a net magnetic field, all right? And so what this means is this will be attracted to a magnetic field. Okay, so when I say result in unpaired electrons, so this is one or more. It only takes one unpaired electron for something to be paramagnetic. So as long as you have at least one unpaired electron, there will be a net attraction to a magnetic field. Whereas diamagnetic, everything is paired up. There is no magnetic field. And so this will be slightly repelled by a magnetic field. Okay, so one's attracted to a magnetic field, one's repelled by a magnetic field. Okay, and so diamagnetic, there are no unpaired electrons. Okay, no unpaired electrons. All right, and so here is a diagram. So diamagnetic, there's my electromagnetic. So here we've got no unpaired. Okay, and there's my paramagnetic sample. I'm going to rewrite this. Okay, and in my paramagnetic sample, we have at least one unpaired electron. Okay? All right, so given that, can we predict electron configurations? So we're going to look at palladium and nickel. Palladium is diamagnetic and nickel is paramagnetic. What can we get from our electron configurations based on this? And then the cadmium ion is diamagnetic. Which electrons come off? Okay. So let's take a look. So let's look first at palladium. Okay. So now when I look at palladium, if you recall in an earlier section, I showed some electron configurations of a bunch of different elements. If you saw palladium, it does have an unexpected one. So we're going to look at two different cases here. What's the expected and what's the actual? Okay, so palladium, let's look at our expected. So if palladium followed all of the filling rules, my expected electron configuration would be krypton 5s2 4d8. Okay, so here I have 5s, 4d, 5p. Okay, so this is what this would look like. So now in this situation, we have two unpaired. We've got two unpaired electrons. Therefore, this cannot if palladium is diamagnetic. So what could palladium be if it's diamagnetic? Because this picture here would be paramagnetic. So given that I need 10 electrons past krypton, what could I have that would give me a diamagnetic sample? Looks like this. We have no 5s electrons, and we have a 4d10. Okay, so we have no unpaired electrons, diamagnetic, matches. Max's experimental data. Okay, we're good to go there. All right, now nickel. Okay, nickel, we're told, is paramagnetic. Okay, so our expected configuration there is argon, 4s2, 3d8, so 4s, 3d, 4p. Would look like that, and this is good. 2 unpaired. Okay, 2 unpaired electron means we are paramagnetic. All right, so now let's look at cadmium. Okay, so cadmium, look at the ground state first. So before it ionizes. Okay, so krypton, 5s2, 4d10. All right, so our problem tells us that cadmium, when it forms its ion, my +2, is diamagnetic. So what do we lose so that we're diamagnetic? We lose those 2 5s electrons. So we're going to get krypton, 4d10. All right, and so there is our magnetic data as related to our electron configurations.